Hi everyone. Today we're going to talk about topic Unit 5, Lesson 11, and we have really important log properties to talk about today. So in your notes, you're going to title your notes 5.11, and then you can also title it Property of Logs. And in class, we're going to do some discovery about like what that means with properties of logs or like how they come about. But right now, we're going to do a little bit of discovery and mainly just you need these properties written down in your notes. So let's use the logarithmic table to calculate the specific logarithms. If I punched into my calculator only the values of log 1 through 9, I would be able to find almost any log or approximation of log. So that's what we're going to do. In class, to recap, if you see something like log of 80, immediately, I'm going to zoom in a little bit, immediately you know you can write this as log of 10 to the first power times 8. And we have a very special property of log that we've been talking about for the past couple days, and the fact that we can break up that this is the log base 10 to the first, plus this is the log of 8. In my scratch work, say I have scratch work over here, scratch, log 10 of 10 to the first power is equal to what? And I think to myself, do the swirl. This is my base. If I multiply it by some value, what would give me 10 to the first power? And then that answer would be 1. So log of 10 to the first power is just 1. And then we're going to add log 8. And log base 8 is right here. So we're just going to add that in as 0.903. So together, log base 80, without actually punching log 80, we're going to get 1.9031. So what properties did we use? In your toolbox of properties, you need to include the following. Log of m times n is equal to the log of m plus the log of n. So if we have something times something else, then we also have the two logs put together. We also have this one. We just use this one. Log of 10 to some power times some other number is going to be that number k, in the first example is 1, k plus whatever log base b was. So far you have two properties. We're going to add some more in. Let's do another practice. Log of 6 tenths, hundreds, thousandths, 10,000, 100,000, 600 thousandths. Now, let's rewrite this. Log, this is 10 to the 1, 2, 3, 4, 5, 10 to the negative 5 power times 6. I'm rewriting this number as 10 to the negative 5 power times 6. Let's break this up again. Log 10 to the negative 5 plus log to the 6. And this is our k value. This is this logarithmic property right here. So it's going to be negative 5 plus, and then we go look, what is log of 6? Log of 6 is this number. And just using this table of 1 through 9, we're able to find out what is the log of this very, very small number. Now, 0.7752, which then will equal to negative 4.2218. Notice, negative log, small decimal. There's another pattern. So what properties did we use? We used both of these properties here. Let's move on to some different properties. Example 2, in your notes, example 2. Using the table above, approximate the following values. So what I did was this side was given to me. These values were given to me, and then these sides I punched into a calculator. So go ahead and pause the video right now and write down these values in your table. It'll be worthwhile, otherwise you won't remember where these magical numbers come from and your notes will be a waste. So pause, write down this table. Bonus, tomorrow in class, you will have already written this down, so you are indeed coming to class prepared. So pause and then come back. Hopefully you paused and you were able to write down these values in a table. And let's use the same log properties. So remember, we had log of m times n is equal to log of m plus log of n. All right, log 14. Let's zoom in a little bit. Log 14, well, that's equal to log of 7 times 2. So now we just have to find what is the log of 7 plus the log of 2. Log of 7 is right here. So that's equal to 0.8451 plus the log of 2, which is up here, and that is 0.3010. And together, if you add that in a calculator or in your scratch work, you just lined up your decimals and you would add it, you would get, oh man, I didn't even write it down. I can do this in my scratch work. 0.8451.3010, and I'm going to add this up. 1, 6, 4, and 11. My decimal place stays the same. 1.1461. All right, let's try that with log of 35. Log of 35 is log of 7 times 5, which is equal to the log of 7 plus the log of 5. Which is equal to, what did we say 7 was? I'm going to change colors here. 7 was 0.8451, and log of 5 is 0.6990. And together, if you add them in your scratch work over here, you are going to get that the value is 1.5441. I don't know what the log of 35 is. On this table, I know that the log of 36 is 1.55, so 63. So I know it needs to be a little bit less, and it is. But I didn't need to know. Really, the only values I need to know is this table. If I give you this table, you should be able to figure out almost any value of log, given the properties you already know. So powerful, the properties you already know. Okay, let's do another example. Let's do log of 72. So this is log of, let's do 8 times 9. So log of 8 plus the log of 9. Do I have another table over here? Where's my other table? I have to go back and look. Okay, log of 8 is 0.9031. 0.9031 plus the log of 9, 0.9542. 0.9542. Together, without ever punching in the log of 72 in my calculator, I'm able to tell that this is going to be 1.8573. Again, these two numbers right here, it's okay if you just write this down in your scratch work and you just add. That's totally okay. You don't actually need a calculator. Those of you who forget to bring your calculators, these problems are for you. Okay, last bit. We are going to summarize all the properties that we know. We know 2 properties. Let's go get them. Let's go get the 2 properties that we know. I wrote them down multiple times. Which one looks better? This one. We're going to use these 2 properties. And can I drag this? Will you let me? Will you let me move you? We're going to use these 2 properties to solve these last 3 examples, and then that's it. I made a copy of the table here. You can look above on your table if you're wondering, but the most important right now is this decomposition of logs, which means you're going to take a big number and you're going to break it down to a smaller number. That's called decomposition. So when you write your summary, you can use this word. I decompose a log of a large number into smaller numbers that I know values of. Go ahead and repeat that last part and write that down for your summary. Okay. log of 10 to the second power, because this is 2 zeros, times 3 times 7. Now we have 3 products in here. That's okay. It still works like this. Log of 3 plus log of 7. So now we have 2. That's this property. Log of 10 to the k is equal to k. Maybe you have to add this part into your properties. So we have 2 plus log of 3, which is 0.4771, and log of 7, which is 0.8451. And then if you actually add them all together, you will be able to get this beautiful number that is 3.3222. Okay, let's try this again with this log value. It is a decimal, so you can predict you'll probably get a negative number. So we're going to get 1, 2, 3, 4, 5 ice cream scoops. So we have log of 10 to the negative 5. We're moving the decimal to the right. So we're going to go down exponents. Times 49. I guess I should have explained that better. 49, I'm going to break down into 7 and 7. So now I have log of 10 to the negative 5 plus log of 7 plus log of 7. So this property we've seen over here, that's negative 5 plus 7. We've been using this number a lot. 0.8451 plus 0.8451. And total, we're going to get a negative number, just like we predicted. And it equals that value. One more example. Hang in there, people. Okay, this is going to be the log of 10 to some power times 42. So 1, 2, 3, 4, 5, 6. 6, which is also equal to the log of 10 to the 6th times, let's say, 7. We've been using that one a lot. And 6. So we're going to break this up. Log of 10 to the 6th plus log of 7 plus log of 6. And this is going to be 6 plus, of course, log 7 that we've used in pretty much every example, 0.7782. And together, it's going to be 7.6232, which is not that big of a number. Even though that 42,000 is pretty far on the number line. Okay, finally, summarize. Box, highlight, star those properties that we were talking about. Use the word decomposition in your summary. There's these 3 properties. Bring them to class because we're going to do some discovery. And if you know that, it'll make your life easier. Okay. Bye, everyone.